So we are now in question 2C that reads that ABC Limited has recently developed a new product named X. The demand for X is expected to be low, medium, or high with the probabilities of 0.25, 0.45, and 0.3. So we have those figures. The product is to be manufactured at a small or scale, some small or large scale production with the following annual profit estimates. You are required to advise ABC Limited on the best course of action based on the following approaches. That is what you are supposed to do. So we are in the paper of May 2017. And specifically, question 2C. And this one is also from probability theory. From probability theory. Probability theory, that is where the question is coming from. So the first thing is the expected value. The expected value. The expected value. So the expected value of X is normally given as sum of xi multiplied by probability of xi. Ariana, what is the problem? Alice, good evening. Okay, for Wajiro and Alice, are you getting me well? Yes, good evening. Okay, then it should be Eliana's side. Okay. So we start with the first one. Okay. So starting with the small scale production, small scale production, the expected profits will be equal to 40 multiplied by 0.25 plus 140 multiplied by 0.45 plus 180 multiplied by 0.3. So give me the answer to that. Give me the answer to that. Yeah, what 0 says 127. Alice. Okay, the same thing. Thank you. So then we go to large scale production. Large scale production. So the expected profits will be equal to 5 times 0.25 plus 90 times 0.45 plus 280 times 0.3 yeah, 125.75 and Alice. Yeah, good. Confirmed. So the advice is that small scale production is the best, or is the better option. Is the better option because you can see it has a higher expected profit. Then on the basis of minimizing risk, we compute what we call standard deviation. Now, standard deviation is given as the sum of xi minus x bar. You square this, then you raise this to power 0.5, or you get the square root. You raise that to power 0.5, or you get the square root. Sorry, I have forgotten to put the probability. probability of xi you raised to power half. So let's start with small scale production. Small scale production. Small scale production. The standard deviation will be 40 minus 127 minus 127. You square this, then you multiply by 0.25 plus 140 minus 127. You square, you multiply by 0.45 plus 180 minus 127. You square, multiply by 0.3. Then the whole of this you raise to power half. You raise to power half. Then you come and do the same large scale production. Large scale production. I'm a person to see answer this one. Give me the answer for the first one. Give me the standard deviation, the first one. Waiting for the answer. Yeah, 53.01 or 02. We can go by that. 02. Then we do the same thing here. It will be 5 minus 125.75 squared multiplied by 0.25 plus 90 minus 125.75. You square, multiplied by 0.45 plus 280 minus 125.75 squared multiplied by 0.3. So work out that. 106.57, good. See that? 106.57. 57. The next thing that you need to compute is called coefficient of variation. Coefficients of variation. Now, CV is given as standard deviation. You divide by the mean times the 100. Divide by the mean times the 100. So for the small scale, production, CV will be equal to 53.02. You divide by 127, multiply by 100. Multiply by 100, what percent would that be? Uh-huh, 41.75 or 76%. 41.76%. Let's go to large scale. Large scale production. CV is 106.57. You divide by 125.75 times 100. So we can have the summary here. So draw that table so that at least we also remind ourselves on how to use or to go about the three decision makers, how to make decisions. Once you finish drawing the table, up to that point, you write the word finished. Okay, you have not finished drawing. Alice, Ajiro has finished. Oh, okay, sir, you forgot to write. So let's make, remember, when we are in the division theory, we have three types of decision makers. There is one who is called risk neutral. Risk neutral. So risk neutral just make decisions based on the expected value. So for him, he goes for the high, which already we explained earlier. So he will go for the small scale. He will go for the small scale. Risk neutral, comparing this and this, he will go for the high. Him, he does not use standard deviation, so this is not applicable to him. Even coefficient of variation is not applicable to him. Not applicable. In terms of the risk taker, one risk taker does not use the mean. So this one is not applicable to him. Actually, the mean is also not applicable to the risk averse. It's not applicable to the risk averse. Now, risk taker is the one who goes for the highest risk. It's the one who goes for the highest risk. And risk is measured in two items. One is standard deviation, the other one is coefficient of variation. So the higher the value, the higher the risk. So the risk taker, going by standard deviation, you will go for the large scale. You will go for the large scale. Large scale. Then this one, he will also go for the large scale because it has a higher risk. Large scale. We'll go for the large scale. But a risk averse is the one who seeks to minimize risk. Is the one who seeks to minimize risk. So for him, you will go for the small scale. You will go for the small scale. And the same case here, you will go for large scale. You will go for large scale. So this question was asking us to make a decision based on risk averse, ways to minimize risk. So it required this column. But I found it wise to remind you of all the three. So I'm through with that question. Not unless anyone has a question, I would wish to proceed. If you are okay, same. Sorry, this is sorry. This is small. This is small. Sorry. Thank you, Ajiro. This is small. You will go for this one. It has a smaller risk. And remember, I told you, in case the two measures contradicting means the standard deviation is telling you small and coefficient is telling you large. If they want to contradict, you are supposed to take instructions from the coefficient of variation. So you go by the coefficient of variation. It is deemed to be a superior measure. Okay, so if you are okay, type yes so that we proceed to the next question. Zero is okay. Alice is okay. Rihanna, I hope now you are getting us. Now you are getting us. We go to question number 3. So question number 3 says, Mwangaza Limited deals in the production of electric bulbs. A random sample of 10 electric bulbs produced by the company yielded the following results on the lifetime of the bulbs in hours. So we have the lifetime, we have the hypothetical population mean of the lifetime of the electric bulb is given as 4,000 hours. Required, test at a 5% level of significance whether there is a significant difference between the sample mean and the population mean. The sample mean and the population mean. So this question 3A, so question 3A, it is on hypothesis testing. Hypothesis testing. So the first thing, can you tell me whether the population is known or unknown? Is this population known or unknown? Is this population known or unknown? Wakiro says is unknown. Rihanna is unknown. Good. Alice, I've not heard from you. Yeah, it's unknown. Good. It's unknown because you don't have the standard deviation of the population. So it's a case of unknown population. Unknown population. And it's a case of SIGO mean. Is a case of SIGO mean. Now the question has just given us raw data. So if the question has given us raw data, why it is SIGO Eliana is because we have just been given data for one sample, a sample that had 10 items. Remember, a sample is a group of a few items. So this is just one sample. Actually, if you look at the readings, it says A, random sample. A is singular. Is that okay? So we can have some computations. Computations. So the first thing that we require is the mean, X bar. And X bar is given as the sum of Xi, you divide by N. You divide by N. You divide by N. So this is what you shall do. Then I will guide you. Taandika 4,400 plus all the others, back at the last one, which is 5,400. You divide by 10. You divide by 10. So when you have done that, take your calculator now. Take your calculator and set it for regression. You set it for regression. Once you set it for regression, we start entering the value. So the same as 4,400 4400 M plus. Unaandika namba, unafinya M plus. Number M plus. Then 4800 M plus. 3700 M plus. 3900 M plus. 5500 M plus. 4000 M plus. 3700 M plus. 4100 M plus. 4000 M plus. 5400 M plus. Have you finished? Yes, Wajiro. Aris, yes. Eliana. Okay, good. Yes, Eliana. Now press Shift, button number 2. The first item you see is X bar. So press 1 and press equals. Type what you are able to see. Shift, button number 2, 1 equals. Type what you are able to get. Yeah, Aris, I can see yours. Good, 4350. Yeah, Wajiro, good. Ariana, good. So that is how you get the mean for the ungrouped data. That is the mean. Then S, which is the standard deviation, is given as sum of xi minus x bar. You square this. You square this. You divide by n. Then all this, you get the square root. All this, you get the square root. So what we are going to do is like this. So I can bring it down just on my space. So what we are going to do is utachukua hii 4400 minus 4350, you square. Then you say plus all the others, we will go doing the same. Mpaka tufike hii ya mwisho 5400 minus 4350 squared. Now all these you divide by 10. All these you divide by 10, and then you get the square root. You get the square root, or you raise to power half. So ukishaandika hivyo, we go back to the calc. You press Shift, button number 2, and then you can see S is number 3. So press 3, and then press equals. You press 3 and you press equals. Type what you have seen. It can't be 0. Maybe you may consider Alice. Press Shift, button number 2. Okay, good. Yeah. So 665.4. 665.415. 3. Alice, Eliana. I've said you press shift button number 2. The same way we got the mean. Shift button number 2. Ukishafinya 2, kuna kitu iko number 3. Then you press 3 and then you press equals. And then you press equals. Nitakupea hii. Let me know whether you have gotten that. Okay, good. So with those items now, we start our normal steps. The first step you know is usually hypothesis. So in the hypothesis, we will say that the null hypothesis X bar is equal to mu. That is 4350 is the same thing as 4,000. 4,000 is the mean that we can be given for the population. Is the mean that we have been given for the population. The alternative 8A is that X bar is greater than mu. That is 4350 is greater than 4,000. Greater than 4,000. Step number 2 is significance level. Significance level, we are told to test at 95%. So alpha is 0.05. Next is test statistic. Test statistic. So T is given as X bar minus mu. You divide this by S, which is divided by the root of n minus 1. The root of n minus 1. So T calculated will be 4350 minus 4,000. You divide by 665.415, which is first of all divided by the root of 10 minus 1. So work out that and give me the answer. One 1.578. 1.578. Okay, we proceed now to bring the division rule. Division rule. So division rule. So on this side, because we are looking for the greater than, here we will say reject null. And here we will say accept null hypothesis. And then this will be positive t at 1 minus 0.05. And the degrees of freedom will be 10 minus 1. The degrees of freedom will be 10 minus 1. So once you go to the tables and you give me this value. Go to the tables and give me that value. Rihanna, you are saying 3.25. Someone else? Oh, 1.33. Okay. The others? Confirm the figure. Positive 1 point. So Eliana, you need to check yours. I'm getting 833. 833. Eliana, are you able to confirm? Oh, okay. So that is the correct value. If your table is not clear, write 1.833. Okay, so with that now, we will talk of conclusion. Conclusion, we are going to say accept null hypothesis since T calculated is less than T critical. That is 1.578 is less than 1.833 is less than. So after you write that, we will now write the meaning of that. Here's Ariana, see that. So the meaning of that is there is a significant difference. There is a significant difference between the sample mean and the population mean. Yeah, that is the meaning of that. Okay, Wajiro, you're asking SX and DX. DX is for the population and SX is for the sample. SX is for the sample and DX is for the population. So you should always use the number 3. However, even if you use the number 2, it will not create a significant difference in your answer. You still make the same conclusion. The difference is not significant at our level, but if you are doing it at a higher level where accuracy is very important, then we need to pay attention to the difference. But for your case, if you want to be here number 3, but if for some reasons to me number 2, still okay, Yeah. Because hata mwenye ametumia manual na akona decimals, still they cannot get the same answer that you have gotten using the calc. So there is a limit. But at the higher levels where accuracy is important, then you have to be keen on which to use where. Okay. So if we are okay, we proceed to the next question. That is part B. So part B says, Green Furniture Limited manufactures 2 models of plastic chairs, C1, C2 from plastic waste, using 2 automated machines, X and Y. The following information breaks the production of the 2 models of chairs for the coming year. Maximum sales units, selling price, machine time in hours. The maximum operating hours of machine X and Y are at 400, 38, 40 respectively. The maximum quantity of plastic waste available is at 4,000 kilograms. And each chair requires 4 kilograms of plastic waste. The company purchases plastic waste at shillings 50 per kilogram. Variable machine overheads are estimated to be 250 and 300 per machine hour for machines X and Y respectively. All chairs produced are expected to be sold during the period. A computer-generated printout of the linear programming model is as given below. So we are given that, and we are told to formulate the program. We are told to formulate the program. So question 3B, this is coming from linear programming. Linear programming. So in the formulation, I told you there are several steps that you need to take, and those steps are to identify the objective. So the objective is to maximize profits, as you can see. Then the constraints are three. We have the hours and the waste, and then number three is the products. We have two products. So with that, you begin by saying let C1 to be equal to units of products C1 produced and sold. Produced and sold. C2 to be units of products C2 produced and sold. Produced and sold. Then if you get selling price, or let me put it this way. Then if I was to get the product here, then I get the selling price here. I less variable costs. I will get something called contribution margin. I will get something called contribution margin. Selling price minus variable costs, we will get something called contribution margin. So for product C1 and product C2, C1 and C2. C1, you can see the selling price is 1,000. At C2, the selling price is 900. So you minus. You can see in machine X, this one is using 0.5 hours, and this one is using 0.3. Multiply by, when you go down there, you are told the variable machine overhead are estimated to be 250 and 300 per machine hour for X and Y respectively. So there's a 250 and 250 here. Then you minus the ones for Y, which is 0.4 and 0.45. And we are told this is 300. This is 300. Then you minus, we are told the waste quantity, each chair requires 4 kilos. Each chair requires 4 kilos. And each kilo is going for 50 shillings. Each kilo is going for 50 shillings. So work out that and give me the answers. Work out and send me the answers. Oh, Ariana says 555 and 490. Aris and Ajiro confirm whether those figures are right. Okay, they are good. Confirmed. So if you have confirmed, you now proceed and say objective function. Objective function is to maximize Z, which is 55 C1 plus 490 C2. Now subject to 0.5 C1 plus 0.3 C2 is less than or equal to the machine hours in X, we are at 400. And this is machine X hours. Then you proceed and say 0.4 C1 plus 0.45 C2 is less than or equal to 3840. And this is machine Y hours. Machine Y hours. Then 4C1 plus 4C2 is less than or equal to 34,000. And this is plastic waste. Plastic waste in kgs. And remember, I've always told you, you say C1, C2 is greater than or equal to 0. And this is called non-negativity. C1, C2 is greater than 0. So from there, we are told to get the maximum contribution. So if we are told to get the maximum contribution, we will have it arranged like this. We have the products. We have contribution margin. Contribution margin. Now this one, we will have current plus all increase that will give us the maximum. That will give us the maximum. So we have C1 and C2. C1 and C2. So what I'm calling current is what we have computed here. This is 55 and this is 490. Then you add what the question is calling all increase is what in our notes we are calling maximum increase. So ukiangalia hapo kwa the first table, you can see all increase is 261.70. So 261.70. Na huyu mwingine ni 65.00. So if I take the calc, I'll be able to say 555 plus 261.7. This is 816.70. Then 490 plus 65 is 3555.00. Yeah, is that simple? That is part 2. Let's go to part 3. Explain the effect on contribution of the availability of additional plastic wastes and machine time. So here tutaipanga hii. We have resource. Then effects on contribution. Effect on contribution. If quantity increases, by 1, if quantity increases by 1 unit, if quantity increases by 1 unit, although the question is asking for just 2, actually all of them. So let's start with plastic wastes. Plastic wastes. For the plastic wastes, you go to where you can see the shadow price. The shadow price. You say profits will increase by shillings 98.125. That will be the effect. The shadow price. Profit will increase by 98. Then you go to machine X hours. Machine X hours. Then finally, here I will have machine Y hours. So you will say for machine X, profits will increase by shillings 325. And here, profits will change by V, by shillings 0. In other words, profits will not change. In other words, profits will not change. Yeah, okay, we proceed. The next requirement, explain the sensitivity of the changes in so when you hear sensitivity, of contribution margins. Contribution margins. Contribution margins. So here, C1 and C2. Sensitivity analysis, I told you, it is simply about getting the maximum and the minimum values. It's as simple as that. So, we already know the maximum. And because the working is just up there, we will not show the working again. We will just show the maximum. Like that. Current is 5, and 490. Now, if you are looking for minimum, it will be the current. It will be the current minus decrease. Or maybe I should even have put it this way so that the formula supports. It is the current minus decrease that will give us the minimum. That will give us the minimum. So you can see what they are calling for decrease. This is 65 and this is 157. So if you take your calc and say 555 minus 65 is 490. 490 minus 157 is 343. Is 343. It's 343. And then the increase in contribution of green furniture, assuming that the management overcomes the plastic waste constraint. Plastic waste in printing. If it is in printing, there will be no change. No change in profits since machine X hours still remain as a constraint. So for you to have a change, you must overcome the two constraints. For example, and I can use this because you read this. For example, assume you want to leave the house and you want to go to town. But there are two problems you have. One, you don't have fare. And number two, you don't have the house here. Or you don't have someone when you achia watoto. You want to go to town, but huna fare, na huna mtu unaweza achia watoto. For some reasons, if you get fare, lakini bado huna mtu wa kuachia watoto, you still not got come. Pesa iko lakini hakuna mtu wa kuachia watoto, or vice versa. Umepata mtu unaweza achia mtoto lakini bado huna fare, you still not go. You will only go to town if you are able to overcome these two. You get money and you get someone who can be left with your kids. So you must overcome all so that there is a change. Are we okay there? Okay. So if we are okay, we can now go to question. We can now go to question 4B. So question 4C, or rather B, says the table below shows marks scored by 8 students in mathematics and English subjects. You are told to come up with the rank correlation coefficient. So question 4C, that is coming from regression again and correlation theory. Correlation theory. That is where it's coming from. And specifically, it is about what we call Spearman's rank correlation coefficients. So this one is computed as RS equals 1 minus 6 sum of d squared. You divide it by n brackets n square minus 1. N square minus 1. So you now draw the analysis table. And this analysis table, we will have the student here. So the first paper is mathematics. And this one we have maths. And then rank. So we can call this rank 1 or rank M for the mathematics. Then English, we have maths. Then we have rank, that is rank E. So we have difference squared. Difference squared. This is rank M minus rank E. You square this is what we call B square. What we call B square. So student 1, I've got 31 hapa and 56 there. Student 2, I've got 36 and 46. Student 3, I've got 44 and 66. Student 4, I've got 28 and 46. Student 5, I'm going to 56, and 36. Student 6, I'm going to 76 and 26. Student 7, I'm going to 36 and 46. Student 8, I'm going to 96 and 76. Then we will have the total down here. So you can rank those values. Rank those values. So we prepare the ranks. So the highest is number 1. So the highest happened Huyu, this is number 1. Followed by 76, number 2. Followed by 56, number 3. Followed by 44, number 4. Followed by 36. Now that these two have died, where we were supposed to go to number 5, you take 5 plus 6, you divide by 2, and that gives you 5.5. So huyu unampea 5.5, na huyu unampea 5.5. That is what you do. You take the two positions, you divide by 2. Then this must now be number 7, and this is number 8. Then from there, this is number 1 here, followed by this as number 2, followed by this one as number 3, followed by 46. There are 3 of them. There are 3 of them. And we are supposed to go to number 4. So the same number 4 plus 5 plus 6. You divide by 3. And the answer will be 5. The answer will be 5. So this is number 5. This is number 5. And this is number 5. Then this is number 7. And this is number 8. Then 7 minus 3 you square, that is 4 you square, that is 16. This is 0.25. This is 2 you square, you get 4. This is 3 square, you get 9. This is 4 square, you get 16. This is 6 square, you get 36. This is 0.5, you get 0.25. And this is 0. So I'm going to have 16 plus 0.25 plus 4 plus 9 plus 16 plus 36 plus 0.25. I have 81.5. So if I have 81.5, my RS would be 1 minus 6 times 81.5 divided by 8. 8 square minus 1. This will be 1 minus. So times 6 equals divided by 8 times 63. 0.93, sorry, 97. And the answer is 0.03. And the comment is that there is a very big, relationship. So if you have agreed, you agree with my figures, Adika agreed. If there is somewhere we are disagreeing, you let me know. You agree with me, you write agreed. Yeah, I can see we have agreed. Eliana, Wajiro, Alice, are you in agreement? Yeah, good. Then quickly we can try to solve the next one. Quickly we can try to solve. That is question 4C is on simulation. So question 4C is on simulation. So simulation. So as you know, matter simulation, we do the Monte Carlos. So we can just go selling price per ton. We don't have to write the one Monte Carlo. So we have shillings. These are 240, 250, 260, 270, and 280. We have probability 0.18, 0.29, 0.31, 0.14, 0.08. Then we come to yield per acre. Yield per acre. I have tons here. Tons are 70, 75, 80, 85, and 90. Then we have probabilities 0.09, 0.16, 0.24, 0.38, 0.13. Then we have cost per acre. Cost per acre. These are shillings. 12,000, 14,000, 16,000, 18,000, and 20,000. Then we have probabilities 0.14, 0.22, 0.36, 0.26, 0.02. Then cumulative probability at the rate. Cumulative probability. Then we have the rate. Cumulative probability and the rate. So this is 0.18, 0.47, 0.78, 0.92, and 1. So this is 00 to 17, 18 to 46, 47 to 77, 78 to 91, 92 to 99. This is 0.09. This is 0.25. This is 49. This is 87 and 1. So 00 to 08, 09 to 24, 25 to 48, 49 to 86, 87 to 99, then 0.14, 0.36, 0.72, 0.98 and 1, 00 to 13, 14 to 35, 36 to 71, 72 to 97, 98 to 99, Thank you for that. So we are getting two questions from two paragraphs. I want to revise three part questions. So we are getting the two. So when I need you to the next class, I will want next class to be I want you to check before that class. You will check that you know where the class. And it's very important to you. So check check for me question number 2. Check the 2. When we come here, the next part, we can be able to attend that from there, and we go to the better from that point of view, we have a then move aside. Then walk out. Are you so from there, we now do the simulation sheets. Simulation sheets. Simulation sheets, which is also called logic. It's also called logic. So obviously, we will begin with trial number. Trial number. Now this one, we get selling price. We will have random number and then shillings, which we shall call A. Then we get yield per acre. We will have random number, and then we have tons, which I want to call B. Then cost per acre, a random number, and then shillings. This one I call it C. Then from there, I'll be able to get profit per acre. Profit per acre as A times B minus C. So draw that. Once you finish, you tell me finished. Oh, sorry. Huh? What are you saying? At the cost per acre is not B, or the formula will change. That is the way it should be. That is the way it should be. That's the way it should be. So that now we get the revenue. This is revenue per acre, A times B. Because you have the selling price per ton, you have the tons, so you get the 1 acre is giving you how much revenue, you less the cost. Okay, let's begin because I can see maybe I do 3 or 4 because of the interest of time. Trial number 1, the random number you take is 03. So 03 it has a selling price of 240. Random number is 91 here. 91 hapa 190. You take the next random number 38. 38 kuja kutafuta hapa iko kwa 16,000. So ukichukua calculator utasema 240 times 90 minus 16,000. I'm getting 5,600. Send your answers. Great. 5,600. The next one after 38 we have 55. So 55 go up 260. After 55, I have 17. 17 is here, it is 75. After 17, I have 46. 46 ukitafuta huku iko kwa 16,000. So quickly, this will give me 260 times 75 minus 16,000, getting 3,500. Let's just proceed because I make an error you asked me. Number 3, after 46, I have that 2. So that 2 equal hapa, it is 250. After that 2, I have 43. 43 equal hapa, done equal 80. After 43, I have 69. 69 ukimtafuta atapatikana hapa kwa 16,000. So then I say 250 times 80 minus 16,000 is 4,000. 4,000. Number 4, after 69, I have 72. 24, 22. Number 5, I have 61, 96, 30. Number 6, this is what I wanted to illustrate. Tikisha, the next one is that 2. If they get exhausted before you are through with the runs that you want, unaanza kurudia. So sasa tutasema ni 03, hii ni 91. Then number 7, utaweka 38, 55, and 17. So I think at that point we are okay. Is that so? You'll be able to finish. Yes, Wajiro will be able to finish from there. Alice, Rihanna, okay. Alice, okay, good. So we stop there for now. Now we meet on Saturday 2 to 4. On Saturday 2 to 4. Wajiro, we will communicate tomorrow regarding the other subjects, even Alice. We have not yet got quorum for the other subjects, so most likely you will not have them. So if we will not have gotten quorum by tomorrow, we now meet on Saturday 2 to 4 for QA. Thank you so much, and God bless.